Hello friends. This is the last lecture of second law of thermodynamics. So the last topic is the second law efficiency. Okay. So try to understand what is second law efficiency. So second law is efficiency is basically the uh, the actual efficiency. It compare. It is the ratio of the actual efficiency to the maximum efficiency. Okay, so what is given in this here, it indicates about the actual efficiency, or if there is a heat refrigerator or heat pump, there is a COP, and that compare to the best efficiency or COP for devices. Okay, so it is the ratio of actual efficiency or COP to the maximum efficiency or COP. Okay, so consider this is a case one. This is consider this is a heat engine. At heat engine have there is a two temperature reservoir, that is T1 and T2, and consider T1 is greater than T2. Okay, so here there is a heat engine. In between there is a heat engine is there. Heat engine basically absorb Q1 amount of heat from the source and reject Q2 amount of heat to the sink, and there is a W amount of work is there. Now if you want to calculate the actual efficiency, that is basically output by input. So W is the output, and Q1 is the input. So from here you can get this efficiency, actual efficiency, that is equal to W by Q1. And if you want to calculate the best or maximum efficiency, that is equal to 1 minus T2 by T1. Just in 2 or 3 previous lecture we completed this concept. Okay, so here the if you want to calculate the maximum efficiency, this is the formula, that is equal to 1 minus T2 by T1. T2 is the lower temperature and T1 is the higher temperature. Okay, so here the second law efficiency say that it is the ratio of the second law efficiency say that it is the ratio of actual efficiency to the best efficiency. So what is the actual efficiency? That is W by Q1. So W by Q1, and what is the maximum efficiency? That is equal to 1 minus T2 by T1. Okay, so this is the second law efficiency. Okay, this is the second law efficiency. Okay, now consider there is a case 2, that is a refrigerator, and the refrigerator this is the refrigerator, and the refrigerator in between T1 and T2, and consider T1 is greater than T2. So here refrigerator basically absorb Q2 amount of heat and absorb W amount of work, and reject Q1 of amount of heat to the surrounding or the higher temperature. Okay, so now if you want to calculate the actual COP, that is equal to Q2 by W. Q2 is the cooling effect, by W is the work input. Okay, so actual efficiency, that is equal to Q2 by W. So and if you want to calculate the best efficiency or maximum COP, COP means coefficient of performance, that is equal to basically T2 by T1 minus T2. T2 is the lower temperature and T1 is the higher temperature, and T2 is the lower temperature. Now from second law, the efficiency, if you calculate the second law efficiency, that is the COP, second law COP, second law efficiency, that is equal to COP actual by COP best. From here COP actual, that is equal to Q2 by W, and W, and here this is COP best, that is T2 by T1 minus T2. Okay, now consider this is a case 3, and consider this is a heat pump, and the heat pump in between, there is heat pump, and this heat pump is in between T1 and T2 temperature, and basically it absorbs Q2 amount of heat and W amount of work, and reject Q1 amount of heat. So if you want to calculate the COP, that is basically heating effect by work input, so Q1 by W, and there is a efficiency, the COP of T1 by maximum COP, that is to T1 by T1 minus T2. So from here you can get the maximum the second law efficiency. Okay, so this is all about the second law efficiency. Now try to focus on one problem. Okay, try to understand this problem. Same concept is there. Try to understand this problem. A heat pump operates between two temperature limit of 250 Kelvin and 300 Kelvin. So there is a two temperature is there. One is 250 Kelvin and another is 300 Kelvin. Okay. So here the work input required for heat pump is 300 kilowatt. So the W amount is 300. Okay. Now the heating effect produce 800 kilowatt. 800 that means this is the Q2 value. Okay, find out the second law efficiency. Find out the second law efficiency. So for heat pump, there is a heat pump is there in question. There is a heat pump is there. So in question there is a heat pump is there, and heat pump we know the formula, the efficiency formula, that is equal to Q1. Sorry, Q1 by W1 divided by T1 by T1 minus T2. So Q1 the heating effect, so Q1 is the heating effect, that is 800 kilowatt. So 800 divided by work input, that is 300, which is given in this question. 300 divided by T1, that is higher temperature, that is 300, divided by 300 minus lower temperature, that is 250. So from here you can get the value that is equal to 44.44%. Okay, so 44.44%, this is the answer. Okay, so this is the second law efficiency. Okay, now understand this concept. Here there is another concept. Suppose if you want to calculate the efficiency of a heat engine, so this is basically 1 minus TL upon TH. TL is the lower temperature and TH is the higher temperature. Now if you want to increase the efficiency, so here this problem is completed. This problem is completed. Now so here if you want to increase the heat engine efficiency, you must decrease this value or you may increase this value. Okay, so here you may decrease this value and you may increase TH value. So from here you can get efficiency will increase, but the efficiency of heat engine increases by increasing higher temperature, that is heat supplied, and by decreasing lower temperature, that is heat rejection temperature. But decreasing the lower temperature is more beneficial. Okay, so here the decreasing the lower temperature is the more beneficial. So here from here, so here if you decrease this lower temperature, this will be more beneficial. Don't try to increase this temperature. Okay, this is the wrong way. Okay, so here just if you decrease this lower temperature, this will be most beneficial. Okay, so decreasing the lower temperature is more beneficial. Okay, in the same way, if you want to calculate the heat pump, suppose consider there is a heat pump. There is a heat pump is there. Okay, there is a heat pump. So heat pump, we know that the formula of heat pump, that is equal to TH upon TH minus TL. Okay, so here COP COP of refrigerator heat pump increases by decreasing the higher temperature and by increasing the lower temperature, but increasing the lower temperature is more significant. So here if you want to increase the heat pump COP, then TL, the lower temperature heat increases, but decreasing the higher temperature by increasing the lower temperature, but increasing the lower temperature is more. So increasing the lower temperature, if you increase this temperature, the lower temperature, then the efficiency, the COP will be increases. Okay, so for heat pump, if you increase the lower temperature, then the COP will increases. Okay, and in the same way, if this is a refrigerator, and the refrigerator is basically TL upon TH minus TL, and if you want to increase the COP, so if this TL is increases, then COP is also increases. Okay, COP is also increases. So this is written in this here. What is written, that COP of refrigerator and heat pump increases by decreasing higher temperature. So you can decrease the higher temperature and by increasing the lower temperature, but increasing the lower temperature is more beneficiary. Okay, so this is all about the COP for heat pump and refrigerator. So there is another problem you can see, you can do your by your own. Okay, so so in second law of thermodynamics we just understand that in second law what is the primary statement, and so we understand what is source and sink, and we understand the statements of second law, that is Kelvin Planck statement. From Kelvin Planck statement there is a heat engine concept is there, and there is a Clausius statement, and from this Clausius statement you can understand the refrigerator and heat pump. So from this Clausius statement the refrigerator, Judson and heat pump concept is coming. Okay, and next concept we just cover this, that is equivalence of Kelvin Planck's and Clausius statement, and violation of Kelvin Planck statement and violation of Clausius statement. And now after that we just completed Carnot cycle, Carnot engine or reversible engine is there, and Carnot principle and their proof, and important point with respect to cycle or engine. Okay, now thermodynamic temperature scale, this is also very very important, thermodynamic temperature scale, and there is a heat engine and refrigerator is there, heat pump concept is there, and in last lecture we just cover the Clausius inequality, and for case 1 reversible cycle or engine, and case 2 irreversible cycle or engine, and just we completed the second law efficiency. So this is all about the second law of thermodynamics. So this is my handwritten notes, you can download it from the description. Like, share and subscribe my YouTube channel. Thank you.